Okay, Reese, hopefully this will be our last one. I'm going to start with the two easy ones, and then I'll do the more time-consuming one at the end. So we'll start with number 8. You and a friend each toss a coin twice. What's the probability each of you tossed 2 heads? That's really the same as somebody tossing a coin 4 times and getting heads each time, because there's you, and you want to get heads and then heads again, so that's a 1 in 4 probability. Then there's your friend, and he wants to get heads and then times heads is a 1 in 4. And so the probability that you and your friend are going to both do that is 1/4 times 1/4, because the and means times. And so that ends up being a 1 in 16 probability. Okay, that's all there is to that one. I'm jumping over to question 10. I know I skipped 9. We're going back for it, don't worry. But 10 is easy, and then that way we can hit 9 at the end, and that'll be the last one we have to do, because it's a big one. So if Erin finishes her dinner and she's asleep before 9 o'clock, then it's really easy to do that, because you're looking for the probability that she's finishing her dinner and she's sleeping before 9 o'clock. That's supposed to be an S there, sorry. So all you do is times together the two probabilities. So the 60% times the 85% is going to give you a 51%. Now for the second one, the probability that she will finish her dinner or be asleep, so that's a probability of dinner or asleep. And because it's possible for both things to happen, these events are not mutually exclusive. So what we have to do is we have to say, okay, that's the probability of finishing dinner is 60%, plus, because it's an or, the probability of falling asleep is 85%, minus the probability of both of these things happening, which we just worked out above in part A, to be 51%. And so we end up with 145%, which seems wrong at first, because we shouldn't have a probability over 100%, but that's because we still have to subtract the 51. And so that's going to land us at 94% probability for one or the other for that question. All right, now for the doozy. It's not hard. It's just a tree diagram, and it's just a lot of writing and stuff. Let's pick a good color here. What color should we do? How about red? All right. So to draw our tree diagram, we're going to start here, and we're going to go down here to day 1. And there's 2 possibilities, right? There's a possibility that he will golf, which is 95%, and the possibility that he won't golf, which is 5%. So we're going to put golf and no golf. And that's what happens on day 1. All right. So then on day 2, we have to go back and we have to read the rest of the question, because then depending on what he did the first day, there's different outcomes for what's going to happen the first day. So it says if he does golf the first day, there's only a 40% chance that he'll golf again the next day. So let's do that. Here's where he golfed the first day. Only a 40% chance that he's going to golf again. That means a 60% chance that he doesn't, okay? So this is day, let's put it over here, that's day 2 on this line. But we also have to go back here to the no golf guy, and if he doesn't golf, so it says if he does not golf, there's an 80% chance that he will golf the next day. So 80% chance that he golfs. 20% chance that he doesn't. Okay, so this just gets time consuming and messy. So now we have 2 days figured out, and now for day 3 we're going to have to do that again for each of the branches of our tree, and then we'll have what's going on day 3 figured out. So again, if he golfs then there's a 40% chance that he'll golf again, a 60% chance that he won't. If he doesn't golf, there's a 20% chance that he won't, and an 80% chance that he will, just taking the same numbers that we used in the second line of the tree. And so here he didn't golf, so again we've got the 20-80 split for no and golfing here. And on this one he did golf, so we're going to have a 40-60 split, just the same as this one for golf and no golf. And see how messy it gets? So that's your tree diagram, and that's part A of your solution. For part B, the probability that he will golf only on the third day, you have to look just at day 3, which means you're just looking here. And in particular, here's where I get to use my highlighter. We want the ones where he is golfing, okay? And so when we do that, why do I have 4 where he's golfing? I think I should have 3 where he's golfing. On only day 3. Sorry, I told you wrong. Oh no, and I can't make that go away. Can you ignore that? Alright, sorry, I read that wrong. It said, find the probability that he will golf only on the third day. So I was just looking at day 3 and thinking that they were saying what's the probability he golfs on day 3. What they mean is we have to find a branch of the tree where he didn't golf at all until day 3. And so if we go down the branch of the tree, we need to find all the no's, right? So here's a no golf, and then he golfs. Is that the only one? I think maybe for that one, I think it is. So if we look there, there was a 5% chance of him not golfing on the first day. That 5% came from here. And on the second day, there was a 20% chance of him not golfing, so that we could continue on in that direction. And then to get to where he actually did golf, then there was an 80% chance right here. So we're following this branch of the tree from here to here to here. And if you multiply all of those together, I think you're going to get 0.8%. Sorry for messing that up. I guess I'm getting tired. So now if we look at C, and it says the probability that he will golf on exactly 2 of the 3 days, that's where we have to go back and we have to find each branch that has just 2 golfs in it. So for instance, golf, no, that's one of the ones that we want. So for that one, we're going to take 95, 40, and 60. And then if there's others where he golfs for exactly 2 out of the 3 days, we have to keep adding those probabilities in. And so golf, no, golf, no, golf. So here's another one, right? Where golf, no, golf. We've got 2 out of the 3. So we've got 95% times 60% times 80% on that one. And then on the other side, we've got no, and then we need a yes and a yes. And so that's a 5% to the no, that's the 5%, and then an 80% to get to the first yes, and then a 40% to get to the next yes on that one. Now, I think if you add all those together, you're going to get 22.8% plus 45.6% plus 0.16%, and I think they all add up to 70% for you, okay? And that's how you do that one. So I think we're done, but email me back or text me if there's other questions that you encounter, or if you didn't understand anything that I explained there, and hopefully that helped you understand what you're doing here for the data. I won't rub it in too much, but our March break has already started. We don't go to school tomorrow. We have a holiday tomorrow, and it looks like you're writing a data management test. So sorry about that, Rhys, but enjoy the rest of your holiday. Talk to you soon.